Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for the instantaneous decoding of the conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today, we will go through the core concepts entitled as digital image processing in remote sensing. In civil engineering, we rarely use the raw aerial or satellite photos without processing it. So, firstly, we have to need to understand the underlying digital structure, the breakdown related to that digital structure which will be studied physically, seen on the ground, which will be converted into a matrix of numbers that our GIS software can read it. So we will go for the concepts of pixels, digital numbers, and how we can use histograms to assess data quality. So you will understand the anatomy of the digital maps used for the site analysis and the infrastructural planning here. What is meant by digital image, right? So here the rows and columns are displayed with reference to some numbers having rows and having columns. A digital image which is a representation of the earth's surface in the form of pixels with numerical values. So a 2D array of discrete picture elements, that is pixels, which will be the definition of digital image. The objective is to capture, store and analyze spatial information accurately. It works by converting electromagnetic energy into digital signals using sensors. Each pixel represents reflectance value like 24, 65, 35, forming a grid-based structure. The characteristics includes spatial, spectral and radiometric resolutions. So in civil engineering point of view, digital images are used for mapping, land use analysis and infrastructural planning purpose. The intensity of each pixel corresponds to the average brightness or radiance measured electronically over the ground area. The concept is that to an algorithm point of view, an image is a matrix of numbers, not a single picture. These pixels are organized into grid of rows noted as I and columns noted as J. So there will be a relationship in between I and J. It is critical for an engineer to remember that to a GIS algorithm, an image is not a picture, but it is a matrix of numbers. So the ground area per pixel defines your spatial resolution, which is a vital for accurately mapping project site boundaries. The terminology chain from the sun to screen. So the procedure initiated from the irradiance, that is E, and ends at the pixel or the digital number. To understand our data, we must follow the energy path from the sun to our computer screen. It begins with irradiance, the energy hitting the earth through rays of sun, which then reflects off materials, so that this material property is a reflectance. The satellite sensor measures that radiance, which is the energy reflected towards the sensor per unit area. This analog signal then undergoes quantization via converters, transforming it into a digital number dn. For any civil engineer, the digital number is the raw value you see in your GIS attribute table, which represents the smallest addressable element of your map. Spatial resolution. The spatial resolution, which is the most important concept regarding to the digital image processing. In remote sensing, we refer the ground area represented by a single pixel, commonly expressed as a ground sample distance in GIS and civil engineering applications. So the pixel size depends on flying height, which is denoted by capital H, sensor size, which is explained by small p, and focal length with a small f. Where higher flying height increases pixel size, while larger focal length improves detailing. Means pixel size GSD, that is ground sample distance, is equal to flying height h into sensor size p divided by focal length f. So the definition for the spatial resolution is that the ground area represented by 1 pixel. So high resolution imaging, where smaller ground sample distance values provide finer detail and more accuracy, making them suitable for road design, structural mapping, and urban infrastructural analysis purpose. So higher resolution, or we can say that higher spatial resolution, improves accuracy and detail but increases file size, storage, and data processing requirements also. Histogram, in remote sensing, histogram is a graphical representation of pixel brightness distribution in an image, showing how digital values are spread across the dataset. The x-axis represents digital numbers, that is DN 0 to 255, while the y-axis represents the frequency or number of pixels for each brightness level. Histograms help quickly identify image brightness, contrast, and tonal variation, improving interpretation of satellite and aerial imagery. Hence, histogram analysis which supports contrast stretching, feature extraction, and classification by enhancing the visibility of characteristics or features like roads, water bodies, terrain, and land use features. In GIS and remote sensing, histograms assist in terrain analysis, urban planning, and watershed studies, along with the pavement monitoring. Owing towards the mean and standard deviation component, mean and standard deviation in remote sensing are statistical measures which are used to analyze pixel brightness distribution and the image quality in GIS applications. Mean represents the average pixel brightness value of an image calculated from all pixel values and indicates overall image illumination. Standard deviation measures the spread or variation of pixel values around the mean, representing image contrast and tonal variation. The low standard deviation indicates low contrast and uniform surfaces, while high standard deviation indicates greater variability and clear feature differentiation. Mean and standard deviation support image enhancement, terrain analysis, land use classification, pavement assessment, watershed studies, and infrastructural monitoring in remote sensing and GIS methods. The representation, or we can say that the interpretation of histogram in remote sensing helps analysis of image along with its brightness, its contrast by studying the distribution of pixel values in GIS imagery. The x-axis represents pixel brightness value. Histograms concentrated near 0 indicate a dark image, while those near to 255 indicate a bright image. The spread of histogram represents image contrast. A narrow spread indicates low contrast, while a wide spread indicates high contrast and better feature visibility. Histogram interpretation represents image enhancement techniques such as contrast stretching and normalization of clear visualization of topography and infrastructural features on the Earth's surface. With reference to civil engineering application, GIS and remote sensing, histogram interpretation improves road extraction, watershed analysis, urban planning, land use classification, and construction monitoring through better image interpretation for feature detection and extraction. What are the civil engineering applications? Digital images in remote sensing and GIS provide essential spatial information for analyzing, monitoring, and managing civil engineering projects through satellite and aerial imagery. Urban planning point of view, digital image processing supports land use classification, urban growth analysis, and sprawl monitoring for efficient city and infrastructure planning. With reference to hydrology or flood mapping, infrared imagery and low digital number values help us to identify water bodies and flood extents, improving watershed and drainage management. With reference to disaster management, the comparison of pre and post disaster digital images enables rapid damage assessment, affected area mapping, and emergency response planning. Digital images improve spatial analysis, environmental monitoring, transportation planning, construction management, and decision making accuracy in GIS and remote sensing applications. Stay tuned, guys. Happy learning.